Welcome back. In this lecture, I'll talk about Spark jobs and stages. So let's start. Understanding Spark jobs and stages require you to know about the Spark data frame API classification. So let me revise that quickly. Most of the Spark APIs can be classified into two categories, transformations and actions. We also have some functions and objects that are neither transformations nor actions. However, the majority is grouped into these two categories. Transformations are used to process and convert data, and they are further classified into two categories, narrow dependency transformations and wide dependency transformations. The narrow dependency transformations can run in parallel on each data partition without grouping data from multiple partitions. For example, select, filter, with column, drop, etc. All these transformations can be independently performed on each data partition in parallel, and you do not need to group data for performing these transformations. The wide dependency transformations require some kind of grouping before they can be applied. For example, group by, join, cube, rollup, and ag. All these wide dependency transformations require grouping of data on some key and then apply the transformation. Make sense? Great. Now let's talk about the actions. As the name suggests, an action triggers some work, such as writing a data frame to disk, computing the transformations, and collecting the results. Some commonly used actions are read, write, collect, and take, etc. All Spark actions trigger one or more Spark jobs. And that's a super critical concept. Great. So now that we learned about the transformations and actions, let's take an example code and see how Spark runs your code. Here is a super simple Spark application code snippet. What am I doing here? I am reading a CSV file and also inferring the schema. I created an initial data frame and named it survey.df, right? The initial survey.df comes from reading a CSV file and inferring the schema. Make sense? Then I'm repartitioning the survey.df and creating a new data frame. This new data frame is named partitioned survey.df, right? I repartitioned it to make sure that I have two internal data partitions. And you should also know that the repartition is a wide dependency transformation, correct? In the following line, I am taking a data frame of two partitions and applying some transformations. The first transformation is where method, and that one is a narrow transformation. Then I have a select method, and this guy is also a narrow transformation. The third one is a group by, and it is a wide dependency transformation, right? Then I have a count method, and this guy is also a narrow transformation. And that is all about applying transformations. I applied 4 transformations on the partitioned survey.df, and the result goes to count.df. Make sense? Then in the last line, I'm applying the collect method on the count.df, and that's an action, correct? Great. Now let's talk about this code snippet. This code snippet has got 2 Spark code blocks. How do I know I have 2 blocks? Well, that's simple. Start from the first line and look for action. Wherever you find action, your first block ends there, and the following line starts a new block. In this example, my first line itself is an action, right? The read method is an action. So the first block starts at the first line and it also ends at the first line. The following line starts a new code block. Then I'll keep looking for the action, but I find it only at the last line. So my second block starts from the second line and ends at the last line. The point is straight. This example has got 2 code blocks. Why? Because we have 2 actions in this example. Make sense? Great. A typical Spark application looks like a set of similar code blocks. This example has got only 2 blocks, but a large application may have many code blocks. And Spark will run each code block as one Spark job. What does it mean? Simple. Each action creates a Spark job. And that's why we keep looking for actions to separate Spark code blocks. I got 2 Spark actions visible here. So I can assume 2 Spark jobs here. Make sense? Great. So I hope you understand the notion of Spark jobs. It is as simple as each Spark action runs as a Spark job that contains all the transformation of its code block. So in this example, let's leave the first code block and concentrate on the second code block. Great. So here is my code block that terminates with a Spark action. Your application driver will take this block compile it to create a Spark job. But this job must be performed by executors. Why? Because the driver doesn't perform any data processing job. The driver must break this job into smaller tasks and assign them to the executors. So how that happens? Let's see how our job looks like. Here it is. The job starts with survey df and repartition it to create partitioned survey df. Then it applies the for transformation to create the count df. That's all we want to do as part of this job, right? I ignored the collect action for now and we will come back to it later. Great. So this is what we call a logical query plan for your Spark job. I'll talk about query planning in a separate video, but you can get a sense here. Spark driver will create a logical query plan for each Spark job. Remember that. And this example shows how the logical plan looks like. Once you have the logical plan, the driver will start breaking this plan into stages. Let's see how that happens. The driver will look at this plan to find out the wide dependency transformations. I have two wide dependencies in this plan. The first one is the repartition method, and the second one is the group by method. So the driver will break this plan after each wide dependency. The first one becomes the first stage. The second one goes to the second stage. Finally, the last one is the third stage. Great. So here we are. My logical plan is now broken into 3 stages. Each stage can have one or more narrow transformations, and the last operation of the stage is a wide dependency transformation. Make sense? Great. Spark cannot run these stages in parallel. We should finish the first stage and then only we can start the next stage, right? Why? Because the output of the first stage is an input for the next stage, isn't it? So whatever we see here is one Spark job and it is broken down into 3 stages. All the stages can run one after the other because the output of one stage is input for the next stage. Make sense? Great. But how the output of one stage goes to the next stage? Let's try to understand that tracing it from the first stage. What am I doing in the first stage? I am reading survey df and repartitioning it to create partitioned survey df. How many partitions do I have in the survey df? Let's assume I have a single partition. How many partitions do I have in the partitioned survey df? 2 partitions. Why? Because I wrote my code to repartition it and create 2 partitions, right? So it should look like this, isn't it? Great. So this entire thing of stage 1 becomes a task. And the final output of the stage must be stored in an exchange buffer. Let's call it write exchange. Make sense? Now the output of one stage becomes the input of the next stage, right? So the next stage starts with the exchange buffer. Let's call it the read exchange. Spark is a distributed system. So the write exchange and the read exchange may be on 2 different worker nodes, right? It may be on the same worker, but it can be on 2 different workers. So we must consider a copy of data partitions from the write exchange to the read exchange. And this copy operation is popularly known as shuffle sort operation. The shuffle sort is not a plain copy of data. A lot of things happen here. But you do not need to worry about all that. We simply learn that the shuffle sort will move data from the write exchange to the read exchange. That is all. But do remember some points here. The stage ends with a wide dependency transformation, and hence it requires a shuffle sort of the data. The shuffle sort is an expensive operation in the Spark cluster. It requires a write exchange buffer and a read exchange buffer. The data from write exchange buffer is sent to the read exchange buffer over the network. Make sense? Great. Now let's come to the second stage. The read exchange has got 2 partitions. Why? Because I created 2 partitions in the write exchange of stage 1, right? And I also configured Spark shuffle partitions to ensure I preserve those 2 partitions in the read exchange. So I'll have 2 input partitions here. And now I can run these transformations in parallel on those 2 partitions. So this is how it looks. Make sense? Spark can execute the same plan in parallel on 2 partitions because I have 2 partitions. And this is what we call a task. So I can have 2 parallel tasks in stage 2. Stage 2 also ends with a wide dependency transformation, right? So we again need a shuffle sort operation here. The connection between stage 2 and stage 3 looks like this. Now let's assume I am still keeping 2 partitions. So my stage 3 can also run parallel like this. Make sense? And this is how the final execution plan looks like. So the Spark driver starts with a logical query plan of a job and converts it to a runtime execution plan. And this is how the runtime execution plan looks for my example Spark job. Make sense? And it helps you understand the following concepts. Let's quickly revise all these terms. Spark creates one job for each action. This job may contain a series of multiple transformations. The Spark engine will optimize those transformations and create a logical plan for the job. Then Spark will break the logical plan at the end of every wide dependency and create 2 or more stages. If you do not have any wide dependency, your plan will be a single stage plan. But if you have n wide dependencies, your plan should have n+1 stages. Data from one stage to another stage is shared using the shuffle sort operation. Now each stage may be executed as one or more parallel tasks. The number of tasks in the stage is equal to the number of input partitions. In our example, the first stage starts with one single partition. So it can have a maximum of 1 parallel task. We made sure 2 partitions in the second stage. So we can have 2 parallel tasks in stage 2. If I create 100 partitions for stage 2, I can have 100 parallel tasks for stage 2. Make sense? Great. The task is the most critical concept for Apache Spark job. We learned all of this so we can reach the task level and understand what a task is. The task is the smallest unit of work in a Spark job. The Spark driver assigns these tasks to the executors and asks them to do the work. The executor needs the following things to perform the task: the task code and data partition. So the driver is responsible for assigning a task to the executor. The executor will ask for the code or API to be executed for the task. It will also ask for the data frame partition on which to execute the given code. The application driver facilitates both these things to the executor, and the executor performs the task. Make sense? Great. That's all about the job execution plan. You must understand and remember all these terms and their meaning. Now, let's see how this plan fits into the cluster. So here is my Spark cluster. I have a driver and 4 executors. Each executor will have one JVM process, right? But I assigned 4 CPU cores to each executor. So my executor JVM can have 4 parallel threads, isn't it? And that's the slot capacity of my executor. It looks like this. So each executor can have 4 parallel threads, and we call them executor slots. The driver knows how many slots do we have at each executor, and he is going to assign tasks to fit in the executor slots. So for this configuration, let's assume the driver has a job stage to finish, and you have 10 input partitions for the stage. So you can have 10 parallel tasks for the same, right? Now the driver will assign those 10 tasks in these slots. It might look like this. All the green slots are filled. This assignment may not be as uniform as I showed here, but let's assume it is as shown here. But we have some extra capacity that we are wasting because we do not have enough tasks for this stage. Make sense? Now let's assume this stage is complete. All slots are now free. Now the driver should start the next stage, and we have 32 tasks for the next stage. But we have 16 slots only, right? That's not a problem. The driver will schedule 16 tasks in available slots. The remaining 16 will wait for slots to become available again. Make sense? Great. That's how these tasks are assigned and run by the executor. However, we didn't talk about our actions, right? This example had a collect action in the end. The collect action requires each task to send data back to the driver. So the tasks of the last stage will send the result back to the driver over the network. The driver will collect data from all the tasks and present it to you. In my example, I wanted to flush the result into the log. So the driver will do the same. If you had an action to write the result in a data file, in that case, all the tasks will write a data file partition and send the partition details to the driver. The driver considers the job done when all the tasks are successful. If any task fails, the driver might want to retry it. So it can restart the task at a different executor. If all retries also fail, then the driver returns an exception and marks the job failed. Make sense? Great. That's all for this video. See you again. Keep learning and keep growing.